The session will be started in few minutes.
Sir, good afternoon, sir. Raman, sir.
Good afternoon, madam. Am I audible?
Shall we? Yes, sir. Shall we start, sir?
Yes.
Sir, few minutes, sir.
Okay.
Welcome to all the participants. A very good afternoon to all of you. So today is the fourth day of our session. So myself, M. Kaladevi. Myself, M. Kaladevi, Assistant Professor of IT Department. Now I'm going to introduce our today's speaker. It's my pleasure to introduce Dr. B. Venkat Raman, an eminent academician, researcher, and educator in the field of computer science and engineering. Dr. Raman holds an MTech in a computer science from JNTUH College of Engineering and a PhD from Usmania University. He is currently serving as the head of the Department of Computer Science and Engineering at RGUKT, Basar. With over 15 years of teaching experience, Dr. Raman has made significant contributions to both academia and research. His doctoral research focused on color imaging classification using quantum computing, demonstrating his experts in advanced computational techniques and emerging technologies. His research inserts span a wide range of cutting edge areas, including quantum computing, artificial intelligence, with a focus on deep learning, data mining, and natural computing. So, Dr. Raman has guided numerous student projects, published research papers in reputed journals and conferences, and actively contributes to the advancement of innovative technologies. His extensive experience and deep understanding of emerging trends in computing make him a highly respected resource person and an inspiring speaker for this faculty development program. We are honored to have Dr. B. Venkatraman with us today and look forward to gaining valuable insights from his expertise and experience. Thank you.
Thank you, madam. I hope my screen is visible.
Yes, sir.
So, good evening to all my colleagues, my fellow teachers. So, I am Dr. B. Venkatraman, and we'll be talking about building a private GPT for any organization today. So let us get introduced to it first. We'll be talking about architecture, implementation, and some applications of having a private GPT for any organization. So as we are all academicians, I'll be concentrating more on academic organizations like colleges and universities for a GPT. So at the end of the session, the participants will be able to understand the architecture of private GPTs. So the chat GPT and other LLM generative AI models that we use are generally the public GPTs. And what I am going to talk about is having a private chat GPT kind of thing for us. So we'll be able to understand the architecture of a private GPT system, differentiate between public LLMs and enterprise or private GPTs, and we'll be understanding the retrieval augmented generation. So RAG model, the significance of RAG model, and then learn about some vector databases and embeddings, how these embeddings are created and how they are going to help, and technically how are we utilizing the vector databases, that will be understanding. And then we'll also design a private GPT for their organization. I'll give some code snippets related to that, and then explore agentic AI extensions for. So along with Gen AI LLMs, we'll also try to identify or try to explore, agentic AI extensions for organizational use cases. So mainly what I'm going to try to say is how when there is some information given to it, instead of a human being answering questions from it and giving you the information time to time, the system or the machine learning agent, or you can say your AI agent, is going to answer this. This has started the methodology. This problem has been started from rule-based systems. Initially, we used to create rules that the sentence has to be like this, and when we have to retrieve based on the set of rules, the system is to used to generate answers for us. So the rules could be, based on some English grammar kind of thing, or we have set of particular words, and whatever words were given will used to be mapped to a particular set of words, and information was retrieved from that. So rule-based systems, it is the problem was with that is it will be able to work only with that set of rules, and you need to generate a very huge set of rules if you want a system to be generalized. So if it is a very small system and you want answers only from a paragraph or something like that, rule-based systems is fine. But when you have loads of information and you have to create rules for different types of questions, and another problem with rule-based system is the questions have to match with one of the rules which are stated. So if it is not matching with the rules which have already been given, then your question is like out of syllabus for it. So generating, you need to generate a huge number of rules, and the system has to match. Even the sentences in the paragraph have to match with the rules. So that was a bit complicated for generating, generalized GPT. Then came our machine learning. With machine learning, we had artificial neural networks, as well as some algorithms like KNN algorithm, naive Bayes algorithm, and all. So based on the text that we have, we used to create it as a data set kind of thing with the existing text, and we used to generate with machine learning algorithms the nearest answer. But again, we have many limitations with machine learning also, because the system has to train itself for the text. And when you train a system using machine learning, only the set of data that you have given was mainly trained. So the limitation is again having, if you want to train a huge amount of data, that would create a problem. And machine learning was also suffering from some problems of accuracy. For that, we had deep learning architectures to improve more accuracy and efficiency for that. And after deep learning, the problem with deep learning is it will not generate answers for it. Generating answer is different from just retrieving the answer. So if you have some system and you have some set of text, it will retrieve one of the sentences and generate it and give you as answer. Whereas when generative AI is there, which is going to be today's topic, it will generate the answer. When you know the fact, what is the answer, then it will generate the answer based on the given context. So the generation is helpful because if you retrieve a sentence or an answer from the existing text, you will not be able to, if the person is not known to the entire knowledge base that the system has, then the particular user will not be able to understand the context, or probably he or she will require a simplified context or maybe some examples for it and all. So a knowledge base which knows the entire context should be able to generate required examples, and should be able to generate some different simplified text, or maybe something particular about a particular context. These kind of generations, it should be able to do it. Now, Agentic AI, addition to Gen AI, what it is doing is, along with the information retrieval or knowledge retrieval, it is able to perform some actions also. We'll be seeing the Agentic AI extensions to our Gen AI problems. So, what is the main task of private GPT? When we have so much of it, we are going to stick to private organizations. Organization could be, hospitals, schools, colleges, and some companies and also. So each organization has its own set of policies, maybe manuals, circulars, notices, emails, and we have some MOUs, when particularly concerned, as I'll be talking more about the academic institutions, we have some MOUs, we have academic calendars, we have timetables, and we have, our circulars, notices, and all this information, different forms of information. We have photographs and videos of a particular cultural event that is conducted in the organization and whatnot. So there's a huge set of information that is there, and I want some system that will answer my query whenever I require information. For example, if a timetable and timetables are given, I want to know, when is a particular XYZ faculty is free on Thursday. Or else immediately I want to know, are the students of first year BTech free on Saturday afternoon. So whatever information I want, and sometimes I want to schedule something and the GPT should help me. So they are free at this particular point of time and they are occupied here. There are two faculty which are who are handling the same subjects. So these kind of answers should be generated by the information that is provided. And the challenge is we are having huge amount of data, and that too completely various forms. In various forms, we have the data. So some are in PDF, some are in audio files, some are in video files, some are as data text, some are as emails and images, etc. So there are so many various types of data, and we need to mine the information from that knowledge base. That is the main problem. Knowledge exists means we have the entire data with us, but it is difficult to access. What is difficult? The difficulty is when we want the answer to a particular question, which type of data is required among the entire huge amount of data that an organization has. Which data has to be existing and how to mine knowledge from it is the question, and from long back. Now, Gen AI is we are doing this. We were solving this problem using data mining techniques and ML also. But Gen AI is a more exclusive technology that will create high impact in solving this problem. Question: can we create an intelligent assistant that knows everything about organization? Yes, private GPT is the answer. So this will help our administration. This is going to help the management. This is going to help all the stakeholders, the employees who are there, and the customers who are there. So for everything, we used to have automatic telecaller machines. So that used to have a fixed set of FAQs, frequently asked questions, and answers for it. And that is a starting point of the problem that we are going to solve now. Private GPT is an answer. Private GPT can answer questions from all. You have your own website also. So website is also a source of information about your organization. So this solution we are going to explore today. So as we have already discussed, artificial intelligence is the system inculcating intelligence into the system, but then Gen AI will be able to generate your text, images, audio, code, videos, etc. As we have already discussed, why not normal artificial intelligence? Because a normal artificial intelligence has the intelligence to understand and create answers from the existing text mainly. But the generation is required because there are different types of users. For example, if a student asks question about the university, it has to be explained in a different manner. If a parent asks, it has to be explained in a different manner. If an employee asks, as employee will be more aware of the university or the organization, the answer should be a bit more, different from the way we answer to a student or a parent. So if the administration asks, the answer should be in a different way. So generating the answers according to the context or according to the user as per the requirements of the user, as per the requirements of context is very important. That is the main role of Gen AI. So some publicly available GPTs are Chat GPT, Gemini, Cloud, and Copilot. These are very famous GPTs that are used in public today. This word, large language models, is quite familiar these days. So what are the importance of large language model? This large language model has the capability to understand or summarize, have different functionalities that can be performed on the given text. It has got all the functionalities inculcated in it, tokens, that is the words or sentences that you want to divide them, and then convert these textual words into embeddings. Embeddings is the way by which we store the data about the text so that we can mine knowledge easily. And then we have some transformer architecture, the deep learning architecture that is especially used for uh, converting this question into answer from the given context. And then attention mechanism. Attention mechanism is a special thing. Attention mechanism, you need to, when an answer is to be generated, you have some points to be given more attention when compared to the other text, especially when it comes to a particular context or a particular user. So we have this attention mechanism also in large language models. LLMs are powerful while generating these answers to the questions. LLMs are very powerful because they're already trained with huge amount of data. So they have the idea how to generate sentences, how a particular language sentences are formed, and what context the people are talking about. If a particular, based on the history of charting of a person, it can also understand the intentions behind the person, the questions, and the work that he has to do based on the questions. So it understands the context. It is already trained on massive data sets and also able to generate sentences in your particular language with the simplicity or difficulty, complexity, or technical words. It has all capabilities regarding that. That's why LLMs are very powerful. We can directly utilize them in our GPT systems. So previously we had, when we used ML and DL, we had a problem of training it based on our requirements. But now these LLMs are already highly trained. So we can directly utilize them in our systems or in our projects and create a major impact on that. Now, we have all these public GPT systems, Chat GPT, Gemini, and all. Why are they not enough yet? So there are some enterprise limitations. Now, what is our main task is we should have a particular private GPT for our organization. Now, why can't we integrate directly with Chat GPT? That's the real question. When it is already trained, when it is utilized worldwide, why can't we have ChatGPT for our particular organizations also? We cannot do that because we have some limitations, enterprise limitations, that is the organization's limitations. That is, we have some privacy, data privacy. Now, if a hospital has to utilize GPT, it has to provide its patients records, their health records, and the tests that they conduct and those records, everything. Similarly, academicians, if you have to utilize your GPT as public, then you have to also give your students records, which could be private. Now we are afraid that the phone that we are utilizing, the mobile that we are utilizing, is actually listening to us. It generates advertisements based on what we talk, not on the phone, but when the phone is on and we are talking to each other, it is listening. And based on that discussion, it is generating advertisements. That's the adverse effect also we have because of the privacy that we don't have in AI today. So if we have to give all this research data, finance related data and all, the privacy is breached. Any organization requires privacy to exist, to compete, and to maintain its own best practices. And some are really dangerous because the students, let us take students or clients, phone numbers, email ID, contact information, hospital records. We cannot disclose the records of patients of a country to other countries also. All this privacy requires, every organization requires its privacy, and it cannot disclose to any public GPT just because it wants a human being to be replaced by AI. Because today they may replace or they may cut down some cost, but in a very near future, they may have to incur a lot of penalty for this. Hallucination is another limitation that these organizations can have. Hallucination means if a public GPT is there about if you ask some question about the organization or something, particular to a particular organization or some specific rules, regulations, or, you have every college has their own academic calendar and all. So if all the academic calendars are put together in Chat GPT's database, then and you ask a question about some particular holiday or say vacation or exams, information from any of those academic calendars. So it may generate incorrect answers. This is called hallucination problems. So why is it hallucination? Because the user may think that it is particular. When I ask question about a particular organization and all, I assume that the answer generated is also related to a particular organization, but then actually the answer is being generated by a public Chat GPT, and it has a mix of databases. And if it doesn't find a particular query's answer in a particular organization's data, it will retrieve from related organizations, and we assume that it is particular to so and so organization, and we will be hallucinated because of that. That could be one more limitation why we need public knowledge cutoff also. This semester we have some set of timetables, and we have a from generated have to be updated from time to time, and if we do not update from time to time, then answers may be not up to date to us, or maybe the current situation may not match with the database that it has. So if we have a particular, just imagine a human being, if he's working from so many years and he's not working in a particular semester, and you ask questions about that particular semester to him, he will not be able to answer. He'll answer from the previous data that he has. Same way, even if you have a public GPT, if you do not inculcate your data from time to time, then the answers are also outdated because of that. So if we have a private GPT, the advantage is we'll be updating our information from time to time. Because of this, whenever you ask a question, it will give you the latest answer from the latest data set. So that has to be there. So based on these problems that we have seen about, we conclude that an organization needs specific or organization specific AI is needed for enterprises to run with AI. If you want to replace human being, at least for knowledge sharing or question answering and giving suggestions and various applications, you require organization specific AI for this. And your public GPT will not be enough. So having understood this requirement, we'll get to know what is a private GPT. A private GPT is an LLM, large language model powered assistant that can securely access and answer questions based on organizational knowledge. By the definition, we can understand that it has access to only our data set mainly. So it is well acquainted with a particular organization's data and is getting updated time to time, as well as it will be able to take up data from various sources in various forms, as we have already discussed, like PDF, PPT, emails, website, and audio, video files, images, and all. So it is having access to all the organization's data, knowledge, and it acts as our assistant to give you all the information whenever required. It is powered with LLM, so we can assume that the efficiency of language generation and identification of the context and knowledge mining is at its optimum. The characteristics that we can find with this is it is secure because it has this knowledge, our organization knowledge is not being shared to the other organizations. It is customized. Customized means based on the organization's work environment requirements and all, we customize the type of answers that we want. Some may require graphical data, some may require images, and some may require if I'm making an ad agency, if I'm running an ad agency, then probably most of the answers that I require will be the images or videos. Similarly, if I
Sir,
Hello, sir. Sir, you are not audible, sir.
Sir, excuse me, sir. Raman, sir, you are not audible.
Hello? Sir, your voice is not recognizing, sir. Hello, sir. Your voice is not recognizing, sir. Please wait due to some technical issue. Uh, hello, sir.
Hello, I'm audible.
Yes, sir. You're audible now, sir.
I'm audible. Okay. Okay. So instead of taking, just theoretical knowledge, why don't we solve one small example? So this could be, we'll take one small paragraph and understand the basics of question answering system. Raju is the father of Ravi. Ravi and Reena. Okay. Ravi is the husband of Reena. Ravi and Ram are brothers. Ravi killed the mouse. These are 4 sentences that we have. Now the question is, who killed the mouse? Or else, who killed the mouse? I'm giving this example just to make aware of, just a simple basic knowledge of question answer system, so that we understand what are embeddings and all, and how they are, helpful, how they are helpful in generating answers. So this is a paragraph. First 4 sentences are the paragraph, are the sentences in the paragraph, and then we have a question: who killed the mouse? So how this answer is generated based on. So initially, what we do is we take the paragraph, and we clean it. Then clean it or pre-process it. What does it mean? We just do, remove the stop words, and as well as we get the root word out of it. For example, we have Raju is the father of Ravi. So we have Raju. Let us remove stop words. Raju is left and father, and then Ravi. Raju, father, Ravi are the main words in first sentence. And in the second sentence, we have Ravi is the left husband. Reena. This next we have Ravi. Next Ram, Ravi, Ram, and brothers. And last sentence is Ravi killed mouse. These are the 4 sentences. Okay, 4 sentences, root words are removed, and so we will have only the stop words are removed, sorry. And then what we do is we remove the, we get the main root word out of all the sentences. Raju, father, Ravi is fine. Ravi, husband, Reena is fine. Ram, Ravi, Ram, brothers. Instead of brothers, you'll just have brother. only the root word is remaining. And then instead of killed, you say kill. These are the root words. We have root words remaining. After that, what we do is we generate the set of distinct words. So we have Raju. We have Ravi. So it's Raju, father. Ravi. And in the first sentence, we have Raju, unique word. Father, unique word. Ravi, unique word. We have written already. Second sentence, we have Ravi, which is already there in the unique or distinct words list. So we'll not write it again. Husband is not there, so we'll write husband.
Sir, excuse me, sir.
And then Veena is not there in the distinct
Sir,
words.
excuse me,
Write
sir.
Veena. And then Ravi already there. Ram is not there, so we'll write Ram.
Sir, excuse me,
Brothers,
sir. Raman,
it's
sir.
not there, so we'll write brothers. Brother. And after that, Ravi is already there. Kill is not there, so we'll write kill here. And then mouse. These are the distinct words present in the sentences. Now, these sentences are actually mapped, or we create embeddings. These are the distinct words. We create embeddings out of it. So there are different types of embeddings that we can create from the text. So here we'll write. So whenever if we find a particular word, we'll write 1. If we don't find it, we'll write 0 in a sentence. For example, in the first sentence is Raju. Yes, Raju is present. Raju is the father. Father is present. And Ravi is present. Hello, madam. Okay.
Sir, yes, sir. Excuse me, sir.
I don't.
Your voice is getting break in between, sir.
Flying, madam. We're actually trying to solve the problem of question system, the basics I was trying to explain. So we have initially removed the remove the stop words, and then we are left with only the root words of a particular, like killed will get converted to kill, and brothers will become brother. So that extra ed, ing, and all this will be removed, and then we'll have only the root word for it, and then now we have written the distinct words present in the sentence. Raju is the father of Ravi. So Raju, Ravi, and father are written. And in second sentence, Ravi is already there in the list, so Ravi is left out. Husband is written, and then Veena is written. Next, Ram, brother, kill, mouse. These are the distinct words present in the sentence. Now, what we do is each sentence we'll convert it into embedding. So there are many types of embeddings, out of which I am making it binary embedding. That is Raju, first sentence, Raju. Yes, it is there. This is the first word. This is the second. Father is the second word. Third word is Ravi. Fourth word is husband. Fifth word is Reena. Sixth word is Ram. Seventh word is brother. Eighth word is kill. Ninth word is mouse. So we have 9 distinct words. Similar, based on the, we are going to create embeddings for the sentence. First word sentence is Raju is the father of Ravi. So Raju is there. First word is there. Father, second word is there. And Ravi, third word is there. So this is the first word. Second word, third word, fourth, fifth, sixth word, seventh, eighth, and nine distinct words. So in the third husband, Raju is the father of Ravi, no husband word, so we'll make it 0. Fifth word, Reena is also not there in the first sentence, so 0. Sixth word, that is Ram, is also not there in the sentence, so it is 0. And then 7, 8, 9, brother kill mouse is also not there, so 0, 0, 0. So this is the embedding for the first sentence, binary embedding for the first sentence. Sentence to become Ravi, Raju is not there, father is not there. So Ravi is there. Third word Ravi is there. And then fourth word husband, yes, it is there. Fifth word Veena, yes, it is there. And again, sixth word, that is Ram, is not there in the second sentence. Brothers 7, 8, 9 are also not there. So this is going to be the second sentence. Similarly, third sentence will see Ravi. So 0, Raju is not there, father is not there, Ravi is there. And fourth word, that is husband, is not there. And then fifth word, Reena, is also not there. Sixth word, Ram, is there. And then seventh word, brother, is there. And kill is not there, mouse is not there. So zeros. This is the binary embedding for third sentence. Similarly, fourth sentence, Ravi, so Raju is not there, father is not there, and Ravi is there, husband is not there, Reena is not there, Ram is also not there, and then brother is also not there, kill is there, and mouse is there. So these are the binary embeddings of the sentences of the paragraph that we have given. So we'll also check the binary embedding of the question or the query that we have. Who killed the mouse? So who is gone? Killed the mouse. Okay, so who is removed? The is removed, killed. We have 0, 0, 0, 0. Killed and mouse. Only last 2 words are there. This is the query. This is the embedding for the query. And then these are the sentences given in the paragraph. So now what we do is, for easy understanding, easy answering of the question, we match this embeddings, this query embedding with the existing sentence embeddings. So we'll see the number of matches. So here we can see the number of, for the fourth sentence, how many embeddings or how many bits are matched. We can see out of 9, 8 of them are matching. And for this third sentence, we have only 1, 2, 4, 5, 4, 5. 5 of them are matching. And for the second sentence, we have 1, 2, and then 1, 2, 6 of them are matching. And for the first sentence, we have only 1, 2, 3. 3 or 4 of them are matching. So the best match is fourth sentence. 8 are matching in this. So we will retrieve the fourth sentence out of it. Ravi killed the mouse. So Ravi killed the mouse will be the answer to the question. Who killed the mouse? Ravi killed the mouse. This is how the basic structure. I'm not involving any Gen AI or any advanced concepts like Agentic AI or something. I just want to demonstrate how embeddings, how word embeddings or say embeddings in a text will help us in identifying the answer for it. Gen AI is advanced version. Great. Okay. Now going back to the since we have gone through the basic structure, let us also see what are the advantages of Gen AI then from there. So initially we had only text, so now we are going to convert PDFs, website, and your data set also. When you have data set with some fields, we can convert that into text again. So all these are converted into text. That will be the layer 1 of your architecture. Once they're done, you do the data pre-processing. So you collect the documents and then clean. Chunking is done. So chunking is nothing but breaking it into chunks. Chunks means some parts of it. And then you generate the embeddings out of it. So the example that I have shown was binary embedding, and now we have some numeric embedding based on the frequencies of the words and various other formulae. We can generate embeddings out of it. The second step would be pre-processing from data cleaning to embedding generation will be done. After that, these embeddings, which are a type of vectors, are stored in vector databases. In traditional databases, what happens is that is your SQL, you just search using the keyword. Now, when it is vector database, what happens is you will be able to search the semantic search can be done. That is based on the context. You can search the answers for it. Now, popular systems, now as you have SQL, Oracle, and MySQL for SQL databases, we have some databases, developed for vector databases, that is FAISS, Roma, Milevus, and PBA. These are some databases that are used to store the vectors of your text data. Next, we see the retrieval engine. Once the data embeddings are stored, now you take up the query from the user. We'll take the query, and then the query is also, if there are some chunks, division of chunks, it is done, and then the query is also converted to vectors. Finally, for generation of the answer, till now what we have seen is just natural language processing and normal machine learning. Now, for generation of better answer and more accurate answer, we use large language models. The open sources we have Llama, Gamma, Mistral, and all these are some open source LLMs that we have. And obviously, the commercial LLMs that we know are GPTs, OpenAI, GPT, and Cloud, and Gemini. We'll have this LLMs, large language models, so that once you know the answer for it, you now have work on generating according to a particular context, according to a person's importance and preferences and all, you generate the answer for it. Finally, you will have user interface where you can interact. The user can interact with the system and generate the answer. It could be a web portal, mobile app, and Slack, some campus ERP, and system related uh, user interface can be utilized. This So this is how the system, we can have the particular system architecture realized. We have seen parts of it. Now the entire architecture, once again, let us see. We have data sources in layer one, which will have all the data about a particular organization. And then the data is given for processing, so the cleaning, root word generation, stop words are removed, and all this chunking, all this pre-processing is done. And finally, your embeddings are generated so that you can store the text information like a vector. So that vector, for storage, we use vector database like Chroma, and then this will help for easy searching of information. And whenever a text comes, we have retrieval engine for it. So the similarity match will be generated by this retrieval engine. And usually now, till now we have seen this example, the simple example that we have seen, we have only one answer generated or one sentences which is most relevant. Usually we'll find confusion, that is a set of more more similar data sets or similar data is retrieved. So it could be from document one, document two, it could be not only some sentences, some documents, and the more relevant data is retrieved, like just like KNN. So K relevant chunks are retrieved from the databases. And then once the answer is identified, we have the role by large language models to play, and they will generate the answer according to the context and user preferences. And finally, it is displayed on the user interface. To deploy, we have some options like, you can have our own system, or else we have our own cloud, or else we can have commercially available clouds like AWS, Azure, like these kind of clouds. Google Cloud is also there. So these clouds also can be used, or we can have integrated when we are developing. So if we are utilizing for our own system and you have a reliable network, then our own private cloud, or else we can have these hybrid version of both the clouds can be used for deploying our application for this. So here we end the session one of it. So I would like to take some queries before we proceed further. We must have understood the significance of a private GPT for a particular organization and the basic architecture. A simple example of how natural language processing will do. Along with that, a basic architecture of how LLMs and Gen AI should help us in generating the answer. So if there are any questions or clarifications or something to be repeated, I am ready to take now. Am I audible? Madam, was I not audible during this session?
Hello, sir. I'm not recognizing, sir. Your voice is not recognizing. Hello, sir. Your voice is not audible, sir. Eh, Hello. Sorry for the interruption. Please wait. uh,
Sir, once again, please unmute and talk, sir. We will check it once, sir. Sir, not audible, sir.
Okay. So I'll just go through the last steps of the example once. What we were trying to do is get the distinct words. Distinct words. So we had Raju, father, Ravi, and then husband, and Reena, Ram, brother, and then kill mouse. One, two, three, four, five, six, seven, eight, nine. 9 words were distinct words in it. So the question is, who killed the mouse? So all the 4 sentences were converted to embeddings, like whichever word is there, that will be 1, and the remaining words will become zeros. This is the first sentence. It is having Raju, father, Ravi, so remaining all letters will be, all words will be zeros. And second sentence is Ravi, husband, Ravi, and then husband, he, remaining all zeros. And third sentence is Ravi, Ram. So Ravi is there, 1, and husband is not there, Reena is not there, Ram and brothers. And fourth sentence is 0, 0, Ravi, kill mouse. So the question is, who killed the mouse? So no other word is there except kill and mouse. So we were trying to find the best match. The question is all zeros with 1, 1. So the best match is we had this embedding is having 8 matches. That is 0, 0, 1 match, 0, 0, second match. This is not matching. Remaining all were matching. So out of 9, 1 is not matching, 8 matches. And here we had somewhat less number of matches were there. So the best match is 4th sentence. The best match is 4th sentence. So the 4th sentence will be the answer. Ravi killed the mouse. So Ravi killed the mouse is the answer. Now in this example, we did not have any LLMs or any GenAI, anything. This is just a basic understanding of how a question answering system works based on embeddings. So the more efficient technology is used to generate answers using LLMs, GenAI, and Agentic AI. So that's what we will be discussing. This is the architecture of the private GPT, and we will do the same thing. The pre-processing will be generating the embedding from the given text. We'll take the data from various sources. We'll do the pre-processing, generate embeddings. And then we'll store the embeddings in a vector database. Whenever a query is given, we'll do the semantic search for the similarity match. So the most similar set of documents or set of files are retrieved. The example which is given is very simple. So we have just extracted the most matching sentence. Instead of that, we'll retrieve the k-relevant chunks or k-relevant documents or k-relevant set of paragraphs or sentences that are matching with the query. Once you get the answer, the large language model plays a role. So based on the attention, based on the context, based on the user preferences, it generates the answer. I would take this. I would like to take queries if the basic example is understood or no. And I would also like to take queries if this architecture of the private GPT is understood or not. Any queries or anything to be explained again, I would like to take queries from this.
Hello, sir. Sir, your voice is not recognizing, sir. Sorry for the interruption. Please wait.
Dear participants, due to some technical issues, sir's voice is not audible. Take a break. Sir will rejoin at 2:40. Please rejoin to the session at 2:40. Meanwhile, we will check the audio. Thank you.
Okay, ma'am. Wait, wait. Wait, sir, ma'am.
So in the previous session, we understood that private GPT is necessary for organizations to work efficiently with mainly the information or knowledge mining. Now, this was the conceptual view or the architecture of the general private GPT. Now, let us dive into how technically we can do the private GPT. And this was the layers of the architecture. Now, let us see how to build and deploy a private GPT in real time. So, along with the normal traditional LLM, we have something called retrieval augmented generation RAG model in building a private GPT. Now, what a traditional LLM will do is a traditional LLM, when you give a question, it will find out the best, similar documents or the similar text of your given text, and then retrieve the answer. If it is an LLM with Gen AI, then it will find out the answer from the context, and then it will regenerate the answer according to the user preferences and the context. So the problem is just generate from normal public database, then there is a problem of hallucinations. Whereas this retrieval RAG, what it does is it will relook into your context again. Like for example, there could be a librarian working in a particular organization, say university. You go to ask, what is the fine payment policy of the university. Then if the librarian just recollects his previous experience and says about a particular fine policy of the university, then it is normal information retrieval. But if RAG is there, it is like the library will again take back the books or the policy documents immediately after the question, recheck the policy document, and then gives the updated information. So it is the RAG. If you integrate RAG along with LLM, then this will be the advantage. That is, instead of just information generating the answer from the previously stored information, RAG will retrieve the most accurate data from the databases again and give you the most updated information. So that is the reason this RAG will give you more accuracy and give you explainable answers, because updated data is there. So it will be more explainable, updatable, and cost effective. Why cost effective? Because if you have to regenerate the embeddings from the entire data set again, then it is computationally expensive. So RAG, what it does is, instead of regenerating the entire policy document or entire data set of your organization, a database of your organization, it will retrieve only the most appropriate documents or most appropriate chunks of the database and give it for processing. So by this, what happens is, along with searching the entire data set, the LLM will search only in the retrieved data set. So both updatable as well as cost effective. This will reduce the cost in searching the answer for the given data set. So when you want to now building a private GPT step-by-step workflow, let us see step-by-step if you have to build it in real time. First is, you need to identify the sources of data. An organization sources of data. So identify that if it is a university, you will have all the academic calendars, timetables, course files, log registers, and all these things. If it is a company, you will have its own policies and constraints of working, and some accreditations or standards by which it follows, and all such things, all documents. So if we have to build a private GPT for our organization, we need to identify first the sources of information which we have. particularly talking about the university, we'll have the website from where we get the data. We have establishment where we have all the circulars, notices, and all. We have attendance registers of students, attendance registers of employees. It could be digital copy or images, and then we have photographs, videos of the events that are taking place in the organization, and then we have some policies, and then all these kind of manuals, yes, manuals and regulations, rules book of an our university. All this they get taken in both all types of data like PDFs and audio video files, etc., are collected first. First step is collection of documents. Then second thing, as we have already discussed in the architecture, we create embeddings. So there are embeddings. Now we have seen the example of a small example. We had 4 sentences and there was one query. We need to retrieve the answer out, the best answer out of 4 sentences. So we have created a binary embedding. In real time, the data that is stored is very huge and it is updated from time to time. Therefore, what we have is we have some models already designed to create embeddings. So we have OpenAI embeddings, BG, E5, Instructor. These are 4 examples of the software technically that will help us in creating embedding of the data set of a particular database of a particular organization. We use them and create embedding. Embeddings are like vectors. So vectors are a set of numbers or set of binary bits or floating point numbers that will give some context as well as the information about the text. And technically, when you want to store these vectors in a database, because whenever a query comes, we have to again go through the vectors and get the best document or best vector for the answer. So for that, we have some vector database software, that is Chroma, FAISS. These are vector databases that we have in the market to store our text vectors. And then we need to connect to the large language model, LLMs. So we need LLMs so that we can generate the language and produce the answer. So some available software for LLMs is Llama, GPT, and then Gemini. Then finally, we deploy the chat application using some user interface. It could be a normal system standalone software or web application, or we have some Android systems mobile application. We can have all various types of user interfaces so that the user can interact and ask questions, and the data set and the LLM will generate the answer from the database. Process, we have some security and governance policies and care that we have to take. First is authentication. We need authentications to understand that only authorized users are utilizing the system. Since we have already discussed that if we are using GPT for a private organization, then the data security, data privacy is of great importance to us. So our organization data should not go to other organizations and leakage or eavesdropping should not happen. Therefore, we need authentication. We have some authentication protocols, technologies available. What you can see is LDAP, Active Directory, and SSO protocols available for authentication and authorization. Authentication will tell us exactly who is utilizing, and then authorization is the level of protection of data. So if we consider a university database, then we have faculty, admin, and student. So each authorized person will have different level of confidentiality. So a student may not be able to access some confidential information, and faculty may be able to access only to some extent, and admin may access all of the confidential information of a university, or it could be, faculty has access to a different set of data, student has access to a different set of data, and admin has access to a different set of data. So based on the authorization level, we need our private GPT to maintain this security according to the authorization levels. Data protection, we need data to be encrypted, converted to ciphertext before we store it, because as we have already discussed that organizations data need to be very much protected and not accessible to outsiders. So access control has to be maintained. Logging of personnel is also should be taken care, because our organization runs on this data itself. So responsible AI. So when AI has to be responsible whenever it gives answers, it should not be biased on any person or in any entity or based on some context. So it should be have fair enough and explainable for its answers, because after all we all depend on its answers for our decision making and all. So the AI that we utilize has to be responsible for all these things. Okay, so this where the security and governance accept care that we have to take in building our private GPT. Then comes the actual the advancement of agentic AI. Whatever we have discussed till now, developing and deploying private GPT was mainly depending on Gen AI, generative AI. So when Gen AI is utilized, the answers to the questions are generated, the information parsing, the information retrieval, the information presentation, all these things were done according to the user context and according to the requirement. But then agentic AI is a bit more advanced. That is, along with the answers, it also has some set of actions that it can perform, especially the software related activities. Like for example, if the faculty asks who is free on Saturday afternoon, then it may answer. But if you ask generate attendance report and email to the HOD, then emailing is an activity. So advancement of this generative AI will be your agentic AI. As the name suggests, AI agents are created which can perform a particular or a set of tasks, so that the entire endeavors are to replace human beings with machines. So whatever the human being can do, we want AI to do all the tasks. So who can utilize this private GPTs with either with Gen AI or with agentic AI? Education. So academic assistants, admission assistant, placement. We have various activities in education. So you need to do admissions, you need to do administration, you need to assign faculty workloads, and we need to take care of placements, alumni information, or maintaining the relationship with the alumni, and all these things can be done using our GPTs. We have a parent-student interaction with the office. They need not come to the office. They can directly access from the AI, and information is given to them. At least the FAQs, which occupy the entire day for various complaints and queries of users, can be addressed using private GPT. Yes, healthcare also uses private GPTs. You have clinical assistants, medical record search. You want which patients are expected to come, which patients are expected to take medicines, and then maybe which patients need more treatment and all such things, extra care and all such things can be taken care by these private GPTs of healthcare industry. We have banking industry and government. Yes. So you have so many queries, especially the government, where if the citizens are not much literate and they want a lot of information or information at any point of time, if the organization is unable to address them efficiently, private GPTs will take care of that, so that their agriculture related information, policies that the government is making, schemes that the government is introducing, the rules and regulations of the schemes that they are using, or everything can be, the information can be passed or answered by the private GPTs. We have various companies and banking also. They can, if you give the data of various customers and all, it can also assess the risk loan. When you give the loan, the risk of giving loans to particular set of customers, and maybe some industry which is marketing and sales. Yes, your recommendation systems become more accurate now. They become more efficient and more accessible with private GPTs. And along with that, information can be given to the stakeholders. Like customers can ask questions and get their doubts clarified. They can take their own recommendations and personalized or customized care by various companies in the industry, service-based companies and product-based companies. So these are the use cases that are the applications of private GPT. Now let us also see how private GPT can be deployed or developed in reality or in real-time application. First thing we need to, we have various packages in and various software in Python mainly to develop a private GPT. Ollama is one such thing. What we need to do is, using Ollama software, we can pull one of the GPT out of it, that is LLM model. We have Llama and Gemma 3. These two are available and we need to utilize one of them. Now the packages that we use is LangChain. LangChain is an LLM software. Mainly when we have a lot of diverse data available, when we have diverse data, that is for an organization, you may have, as we have already discussed, PDFs, audio, and then take text documents, Word documents, and images and all such things. When you have more diverse documents, we need this so that we can parse various types of information and get it into one uniform set of information. ChromaDB is used so that you can store the vectors, the embedding, the text embeddings that are created, various types of embedding based on, you can have some frequency based or say this binary based data sets you can create, and then you can store it in ChromaDB. ChromaDB is a vector database that we are using in this particular. PyPDF is Python PDF reader for your PDF parsing and all. Sentence transformers. So sentence transformers are required because first step is to divide them into chunks. When we have huge number of documents with text, then you need to divide them with chunks, and then you can divide it based on words, sentences and all particular, or based on some punctuation mark also you can divide the text. So based for all that you have support in sentence transformers. And Streamlit is user interface application. So when you want to, interact with the software, you can use various applications like web applications, standalone. Streamlit is one of them, so that you can utilize or query the given, question answering system that you have. So let us see how to utilize these packages. The previous slide was showing the different packages that need to be installed for developing this. There are many commercial packages. Now whatever I'm showing is most of them are not commercial, and you can utilize them for free, most of them. The first one which I showed is LangChain, is an open source framework that enables builders to build LLM powered application, large language application, by connecting language models with data sources, tools, memory, vector databases, and workflows. The first thing is you require support for reading diverse set of data, as well as you need to connect with different software like language models and tools, everything, vector databases and workflows. So to connect all of them, and your parsed information should be there, and therefore we use LangChain from this. So this is the syntax from LangChain community. You import PDF loader, PyPDF loader. PyPDF loader, and here I am showing an example of loading the academic regulations of a university. So I have stored some academic regulations in a PDF form, and using your LangChain package, I have imported PyPDF loader, and I'm loading the academic regulations of the university. The method for storing this, I am using a variable documents and using loader.load. That is, loader is the object for the PyPDF loader, and then with that I am loading all the entire PDF and storing it in documents. Next, I'll split the text. So there are various ways of splitting the text. The basic examples that we have seen is tokenizer, which we used to do from long back. From there, we have this recursive character text splitter. So LangChain has got a package or a class of a text splitter. Using that text splitter, what we do is we split this context, whatever document that we have loaded, we are going to do it with 1,000 chunks and overlap. There is an overlap. Overlap means if we divide the entire document, what is this overlap? Let us assume that this is the entire document. I can divide it into tokens like that, and let us assume it's chunks. So chunks, if I divide like this, I am dividing the text into 4 chunks. 1, 2, 3, 4. This division is without overlap. So this is completely different chunk. This is completely different chunk, and this is different, and this is different. The problem without overlapping is that when you ask a question or a query, when a query is asked, then there could be the information for that query could be in third chunk, but it may be somewhat dependent on second chunk also. Okay, the answer to that query may be mostly in third chunk, but it may be the information or the context or some other related information may be in second chunk also. If we use overlap in making chunks, then this is the advantage of it. So the first chunk, let's say The first chunk may be something like this. The second chunk will overlap. So there will be some overlap. The second chunk and the first chunk will have some overlap. The third chunk and second chunk will also have some overlap. The third chunk and fourth chunk will have some overlap. Because of this overlapping, the inter chunk information or related metadata will be preserved while retrieving the answer to it. That is the reason we are using recursive character text splitter. So recursive character, and there is something called chunk overlap here. So out of the 1000 is the chunk size and 200 is the overlap. That is information from previous chunk is taken into present chunk, 200 bits. Now chunks is equal to split documents. The entire documents will be split into chunks, and then the chunks or length of the chunk is printed as how many number of chunks that you get from the text, you will be getting the output of it. And then from this 200 and yeah, okay. Yeah. So first the text is divided into chunks, and we have maintained the information using overlap. So now we are going to create embeddings from this. So from LangChain community embeddings, this is the package. We import Hugging Face embeddings. So we have seen, I've given a simple example of creating binary embedding. In the real time, we have many classes in, in support in Python for creating various types of embeddings. So Hugging Face embeddings is used here. So sentence, this is the model name. Whatever we can see, sentence transformers, all mini LM L6 version 2 is the model name. Using that model, we are going to create embeddings of the given text. These embeddings are like vectors which are representing the textual information along with the overlap. Why we are creating vectors? Because we want to see the similarity. When we want to compare the textual information, it can be difficult. So comparing the text information with different forms of words. The same run can be running somewhere, can be ran somewhere, and only a person who knows the language can understand that ran, run, and running are similar words. But comparing directly will become difficult. So we use these vectors so that the comparison becomes easy. Running, ran, and everything, all these words will come to root word, and then this root word will be converted to a vector, which is represented by number. So comparison or finding the distance between numbers is easy when compared to find the distance between two different words or two different sentences. That is the main reason why we create embeddings of the text. Once this information is created as embeddings and you store them in Chroma database as vectors, then we require some database for it, software information. So we have already imported Chroma database in the starting slide, and Chroma database will be used here. From LangChain vector stores, we import Chroma. So as we have already discussed, LangChain is the package that supports parsing data from various sources, various different types of sources, as well as we can connect to various tools. Here we are connecting to Chroma database for storing our embeddings. So the chunks that you have created, embeddings, chunks embeddings will be stored in the database, Chroma database, and this is the syntax for it. And db.persist, it will persist as given. Once all your embeddings are stored in the database, what does it mean? The entire information is parsed, the context is preserved, and information is efficiently stored so that whenever a requirement for knowledge comes, it will be easily, parsed, and similarity can be checked easily. Now it's the time for connecting to the local LLM, large language model. So we have already imported Olama LLM from it. As we have discussed, there are two types of LLMs supported. Two LLMs as example it was given, Llama LLM and Gen LLM. So now this model, we are creating an LLM model here, Olama model LLM 3, sorry, Llama 3. This is a syntax for creating the or connecting with the local LLM. Now retriever. What is the use of retriever? Retriever is the main place where you retrieve the most accurate or not most accurate, most similar data from the given database. So if you ask a question and there is a huge database, you have to find out, instead of searching the entire database, you need to retrieve only the most prominent information or most similar information. So like for example, if you want to search for attendance records, it would be not in examination section, but then it will be in your course files. So among all the information that you have, the best suitable or more similar data has to be retrieved. For that, we create a object for retriever. So let us take this example. What is the minimum attendance requirement? Query processing. Docs. What it does is retriever dot get relevant documents of the query. So among the, if you given query as the input, it will retrieve the most relevant documents out of it. Most relevant documents are retrieved, and then the context is taken into consideration. So whatever docs are retrieved, each doc will be considered as the or integrated in the context. From there, prompt, answer only from the context. So from the given, retriever has retrieved the most relevant part of the documents, and from there we insert the or send the prompt, answer only from the context. So from there we take the context and question, and from the LLM we invoke the response of it. And once the response is taken, whatever may be the attendance requirement according to the policy, it will be generated. This is the real-time code, and what the explanation, the simple example that was taken was a paper solvable answer. That is paper, in the paper, if you want to solve, that was a simple example, the example which you have taken, Raju, Ravi, and that one. And this is the real-time development of LLM, private organization LLM. I would like to know if there are any queries in this. Developing a private GPT, the utilization, practical development. if time permits, whenever possible, I wanted to actually show the deployed version of private GPT. Unfortunately, I'm not sitting with that system now. Anything else more than that to be discussed?
Okay, thank you, sir. Thank you for all. Sorry for the interruption. Um, as for the some technical issues, today's section is closed. Uh, as per the schedule, tomorrow section is started in 1 p.m. sharp. Okay, thank you. Thank you for all joining the workshop. Thank you all. Thank you, sir, for a valuable message and valuable content to give for the participants. Thank you, sir. Thank you all.
Welcome all, and thank you, Aurora team, for giving me this opportunity. Thank you.
Okay, sir. Thank you, sir. Yes, sir.